All right, campers, let's go ahead and evaluate these expressions without a calculator. And you can use any method you want. We're not going to do all of them in the video because this is something you guys are all supposed to be pretty up to speed on. So the ones that we don't do in the video, you guys can do on your own and check the key in the notes. Again, I don't care if you use the unit circle, if you use SOHCAHTOA or some other method that somebody else taught you that you like a whole lot better. You know, just keep using it as long as it's pretty fast. Like in other words, don't spend 5 minutes on each of these. If that's what you're doing, then you might want to try a different method because speed helps. Okay, sine of 120 degrees. If we used SOHCAHTOA again, that's basically kind of like what we just did in the last example. So 1, root 3, and 2. So sine is going to be opposite over hypotenuse. So root 3 all over 2. Cosine of 4 pi over 3. 4 pi over 3, that's the same thing as 240. So that's down on quadrant 3. So 180 degrees is right here, so 240 went past it, so how much further did it go? So just subtract 240 by 180 to give you the angle that's inside, so that's the 60. Okay, so cosine adjacent over hypotenuse, so a negative 1/2. That would be your answer. So let's, I'll leave you guys to do part C. Let's do part E, a negative angle. So negative angle just means that you're rotating in the opposite direction. So if it's negative, if the angle is negative, you're rotating you're rotating clockwise. So negative pi over 4 is actually going to rotate down into quadrant 4. So the angle in there, the reference angle is 45 degrees. So there are your sides. So secant is hypotenuse over the adjacent, which in this case would just be root 2. Okay, so you guys can do D and F. Let's go with these, because these ones are a little bit different. So it's like sine of pi. Pi is just totally over on the left side, like right there, that's where it is. So you can't draw a triangle with this. So anytime you're on an actual like coordinate axes, so like straight up and down or straight out left and right, you can't draw a triangle, so you can't use SOHCAHTOA. So instead, you do have to use those unit circle definitions. But the ones that are on the coordinate axes are not that hard because the radius is always a 1. So the point out here is going to be negative 1, 0. So sine of pi, that's just the y value. So that's just going to be 0. Okay, so let's go ahead and do the rest of these since they're all going off of that coordinate there. Cosine goes with the x. Tangent is y over x. So that's just a 0. Cosecant, that's 1 over the y. So that's D and E. Secant, 1 over the x. And then cotangent is the x over the y. So another D and E. So trig functions, they don't have to exist. There are a lot of them that don't. So don't freak out or panic if you're like, oh my gosh, it's not existing. Like trig functions, that's okay. Sometimes that's how it is. All right, moving on into example 6. Suppose the point is on the circle that corresponds to the angle theta. Find the exact values of the 6 trig functions of theta. All right. So with these, we actually can just use the unit circle definition. So like sine of theta is just equal to the y coordinate. Cosine would be the x. And then tangent is going to be y over x. Well, they have the same denominator, so the denominators cancel. So it's just negative 7 over 24. All right. Now, this point, you can't necessarily do that. You can't really go off of the unit circle. You can for these because they're smaller than 1, but if it's bigger than 1, you can't do that anymore. So instead, we can use SOHCAHTOA. So just plot the point. So in this case, we're down in quadrant 4. So over 8 down 15. And then use Pythagorean theorem to give you the hypotenuse, which in this case is a 17. And then you can just run through SOHCAHTOA to give you the functions. Select sine of theta, negative 15 over 17. Cosine of theta, 8 over 17. And tangent of theta would be negative 15 over 8. Okay, so I'll leave you guys to figure out the rest of them. They're basically just the reciprocals. Okay, example 7. Find the exact value of each of the remaining trig functions of theta. So we're given a trig function and a clue about theta. We don't exactly know what it is, we just kind of know things about it. So we know theta is in quadrant 2. Okay, and then I'm going to draw a triangle, and I'm going to use the trig function to label up my sides. So it's opposite over hypotenuse because it's sine. So opposite and hypotenuse. So Pythagorean theorem would give you this last side down there. So that would be the square root of 48, which is 4 root 3. So cosine, and it's negative because we're on the negative x's. So cosine is going to be negative 4 root 3 all over 7. Tangent, that's going to be 1 over negative 4 root 3. So opposite over adjacent, but you have to rationalize it. So negative root 3 all over 12. And the other ones are just going to be the reciprocals. And anytime you're given a trig function, you should always know one of the other functions because it's reciprocal. So in this case, that would be cosecant, and that would be a 7. So I'll leave the other two for you guys to do. So let's talk about this one, do a couple, and then we'll finish with example 8. Okay, so tangent of theta is 5 over 12, and sine is less than 0. So in this case, sine is negative. So we need to put the triangle in the correct spot. Like, you can't just randomly throw it in there. So we have to put it in the place where sine is negative and where tangent is positive. So sine is negative. That's when it's going off the y coordinate, so that's going to be 3 and 4. And tangent, it's going off of both the x and the y. So the numerator and denominator either have to both be positive or both be negative. So they're both positive, that's quadrant 1. Well, that doesn't match up with sine being negative. So then it has to be in quadrant 3. And then Pythagorean theorem would tell us that side is 13. So sine of theta would be opposite over hypotenuse. Cosine of theta adjacent over hypotenuse, and then you guys can get the rest of them. All right, let's do this last example, and then that'll do it for these two sections. Now this problem, I usually would turn my class loose on them and see what they would do with them, but I can't really do that here. So there is a little trick to them. So like cosine of 5 degrees plus cosine of 185. And what a lot of students try to do is they try to add up the angles. You can't do that. You can't add these together. That's not how trig functions work. But instead, you kind of can go off of their signs, like the positive and negative. So like cosine of 5 degrees, that's in quadrant 1. I'm going to draw it down here, have more room. And 185, that's down in quadrant 3. But the reference angle would be 5 degrees. So if you drew a triangle out of them, you basically have the exact same triangle. So if you labeled up your sides, this side would be x, and then this side over here would be negative x. Well, if you added those together, they were just going to cancel each other out. So that's just going to be a big ol' 0. Now the same thing's going to kind of happen over here for 10 degrees and 170. They have the exact same reference angle of 10 degrees. So their x sides are exact opposites. So if you add those together, that's going to give you a 0. Now you can use that same little trick even when they're sine. It's like 3 degrees is in quadrant 1. Well, 357 degrees, that rotates to quadrant 4, but the reference angle is still 3 degrees. I didn't really draw these to scale, but oh well. So it's the same triangle, but this side over here is positive, and then this side over here is negative. So they end up canceling out. And then the same thing is going to happen here. It's the same reference angle, but this one's positive, this one's negative. They cancel out. Now for E, I have a lot of students that are like, oh my gosh, there's so many things in there. There are so many things in there, but kind of look at them. 1 degree and 359. Or sorry, I don't want to do that. One degree and 181. They're the same reference angle. So the cosine of 1 would cancel out cosine of 181. Cosine of 2 would cancel out 182. The 3, 183, so on and so forth. So they're all going to cancel out, but it's because there's a pair. But there's one value in this expression that doesn't have a pair to go with it. There's one that's been left out. So the one angle that doesn't have a pair in there is the 180, because its pair would be 360 or 0, and you don't have either one. And cosine of 180 degrees is negative 1. All right, so that's going to do it for these two sections. Sorry for that kind of lengthy video. But there you go. Go ahead and try the homework. If you have any questions, please let me know. And have fun with them.